So today we're going to talk about Lewis structures. Lewis structures are the fundamental way that we look at covalent bonding within molecules, and the best way to really look at this is through examples. And so let's take our basic water molecule. Now if we're going to draw that via Lewis structures, we'd put the oxygen in the middle, and then there'll be hydrogens either side. And so the way you want to do Lewis structures first is you add up all of the valence electrons that should be in water. So oxygen has 6 valence electrons. So the number of valence electrons is going to equal the 6 for water plus 2 from each of the hydrogens. There's going to be 1 valence electron, so it's a total of 2, and so here we have 8 valence electrons. What we need is for every atom to have an octet, or in the case of hydrogen to have 2 electrons. And so what you first off draw is a single bond, and then make sure every atom has 8 electrons, or in the case of hydrogen 2 electrons, because it's in that first shell. And so each single bond counts as 2 electrons. There's really 2 electrons there. And so you add up the total number of electrons, and it'd be 1, 2, 3, 4, 5, 6, 7, 8. And so there's 8 electrons, and so that would be an acceptable Lewis structure. If we take an example that's a little bit more difficult, we might have carbon dioxide. And so the number of valence electrons for carbon dioxide is going to equal 4 for the carbon plus 2 times 6 for the oxygens. So we're going to have 16 valence electrons. So again, we start off by putting our central atom in the center, and then we join the other atoms like such. To tell which is going to be the central atom, it's usually the atom that is the least electronegative. And so because carbon is in group 14 and oxygens are in group 16, the further right you are in the periodic table, generally the more electronegative the atom is. And so you want the most electronegative atoms to be non-central, but you want the least electronegative atom to be central. And so we start off like this. Then we see if everything has, we go ahead and give everything 8 electrons, and then we check. So everything's got 8 electrons, because in covalent bonding, each bond is shared electrons. So the carbon is going to count these 2 electrons from this bond as its own, and these 2 electrons from this bond as its own. So for the carbon, there'd be 2, 4, 6, 8. Now the oxygen will also count these 2 electrons. So oxygen's got 2, 4, 6, 8 here, and 2, 4, 6, 8 here. I hope that sort of makes sense. It's like the carbon counts those electrons as its own. The oxygen also counts those electrons as its own. And so then we add up all the total electrons, and so the total you don't double count, you just add them up as per normal. So it'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this structure has 20 electrons, but we know that carbon dioxide can only have 16 electrons. So we know this structure is not right. We have more electrons than we need. And so a way to get around that is to add another bond. And so we go to our next structure, which would be, again, the carbon in the middle, but this time we form a double bond. Then we go through and give everything 8 electrons again. and you just check that. So oxygen here's got 2, 4, 6, 8. Carbon's got 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. Then we just add up the total number of electrons, which is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is 18 electrons. But we know that we really need 16 electrons. So this one is also incorrect. We have too many electrons. And the way we use it up is to form double bonds. Because every time we form a double bond, because each atom counts the electrons as its own, you effectively need less electrons. And so the next one would look like this. And we go through and give everything 8 electrons again. So we have carbon with 2, 4, 6, 8. This oxygen with 2, 4, 6, 8. And obviously this one with 2, 4, 6, 8. And so now we add them all up. So it'll be 2, 4, 6, 8, 10, 12, 14, 16. So that's 16 electrons. That is correct, because we know that we really want something with 16 electrons, because we've added up valence electrons. So that is basically how you do Lewis structures. It will get more complicated than that with resonance structures, and so we can have a look at that with, say, the carbonate anion. So if we consider carbonate, carbonate is CO3 2-. So now let's consider how many valence electrons we have. There are 4 from the carbon, plus 3 lots of 6 from the oxygen, so it's a total of 22, plus there's a 2- charge here, so it's a total of 24 electrons. 4 plus 3 times 6 for the oxygens, plus 2 because it's a 2- charge. And so we have a total of 24 electrons. And so we first draw the structure with the carbon in the middle because it's the least electronegative. And we put oxygens around. Then we give everything 8 electrons, and so we need an extra 2 here. So this carbon's got 2, 4, 6, 8. This oxygen's got 2, 4, 6, 8. Obviously the other ones do as well. And so then we add up all the total electrons we have, and this is actually 24. Because it's got a 2- charge, you draw it like that. It's saying that 2- charge is dispersed over the whole structure here. 2- doesn't actually reside on any one of these atoms as such. So I'm just trying to find an example where we do have a resonance case.